So sometimes, guys, you're going to see multiple units. Like you're going to see miles an hour, grams per cubic centimeter. So when you do see multiple units, you're still doing dimensional analysis the same way. What's on the top of one unit is going to cancel what's on the bottom of the next unit. Or you can reverse it. You can say what's on the bottom of one unit will cancel out what's on the top of another unit. So basically, you're just saying diagonals cancel. That makes sense, right? That's good math, right? So let's take a look at this problem here. I'll work through it real quick and show you guys. I think that you're going to get this real easy. 55.0 miles. The tricky part here is this, is that when you write miles per hour, usually we write that diagonal slash. When we're doing dimensional analysis, we want things clearly on the top and the bottom. So this is the way I write miles per hour when I'm doing dimensional analysis. I use a horizontal bar. Bless you. Is it okay to have a unit in the bottom without a number? What number is implied anytime I write a fraction without anything underneath? Okay, so 55 miles over 1 hour. Is that the same thing as 55 miles per hour? Yeah, okay. So it's always going to be okay to write no number on the bottom and just have a unit. At the very, very end here, we want kilometers over seconds. I'm going to do kind of like we did yesterday. You guys still have your notes from yesterday there. I think we had a miles to kilometers equivalent, right? The first equivalent statement you guys took in your notes yesterday was a miles to kilometers equivalent statement. It said that 1 mile is the same thing as 1.609 kilometers. That means if I'm showing my work here, my miles and my miles canceled. I'm left with kilometers on the top and hours on the bottom. Does that mean I'm done with the problem? No, I want seconds on the bottom. So I've got to use another step of dimensional analysis to get rid of those hours. Like I said just a minute ago, if I want to get rid of something on the bottom, I have to put the matching unit on top. Do I know how many seconds there are in an hour? Yeah. There's 60 seconds in a minute and 60 minutes in an hour, right? 60 times 60 is 3,600. So there's 3,600 seconds in 1 hour. So the hours and the hours cancel, and I wind up with units of kilometers on top and seconds on the bottom. So the math we wind up doing is 55 times 1.609 divided by 3,600, which I don't have done yet. All right, so if I'm rounding the small number, the calculator says 0.024581194. We want 3 sig figs, so I'm going to write 0.024, that's 2 sig figs. The next sig fig is a 5, but there's an 8 after it. So I'm going to have to use the 8s around the 5 up. So I'm going to write down that this is the same as 0.0246 kilometers per second. And those two things are the same. 55 miles an hour is the same as 0.0246 kilometers per second. You don't go too fast when you're measuring things in seconds, huh? In a case like this, what we're going to be doing, since cubic centimeters are made by multiplying centimeters by centimeters by centimeters, and if we're looking to get cubic millimeters, the mathematics looks a little bit like this at the most basic level. We can talk about how many centimeters there are in a millimeter. You guys know that one, right? Oh, I should say it the other way, right? How many millimeters are in a centimeter? 10, right? 10 millimeters for every 1 centimeter. That's going to cancel how many of my cubic here? It's only going to cancel one of them, so I still got centimeters squared. What do I have to do? Do it another time, right? Helped out a little bit the first time. Should help out a little bit the second time, right? Put 10 millimeters over 1 centimeter again. That centimeter should cancel exactly one of these squared centimeters. And I've still got one left, right? What's centimeters times millimeters times millimeters? Is it millimeters cubed? Nah, it's not millimeters cubed, right? So we've got to do it one more time. 10 millimeters goes up on top. 1 centimeter goes on the bottom. that centimeter on the bottom still cancels exactly one of those centimeters that's left over. And essentially what I've got is I've got 10 times 10 times 10 times 65.4. So 65.4 times 1,000. Which is 65,400 cubic millimeters. Okay.